Okay, so many of you have reported that rotations is a little difficult, actually more than half of you. So I want to share with you one strategy that comes from that Strategies for Learning Math that I shared with you on a video, I think it was February 3rd. 5 strategies. You can draw it. You can use teamwork, work with others. You can persist, look for resources, and then uh, the last one was work with a simpler model or a smaller scale of the problem. So with rotations, uh, drawing it or visualizing it is going to be the most important. Notice I have this shape here, the triangle. It's partly in the first and second quadrants. If I take the entire sheet of paper, rotate both the axes and the shape, then I am looking at a 90-degree rotation about the origin, clockwise. Negative direction, negative 90 degrees, clockwise. And now I have the ability to imagine or get a visual of where these coordinates are. So let's see this again. My original pre-image, negative direction because this is a coordinate plane, 1, 2, 3, 4, positive direction, negative direction. Negative 90 degrees clockwise. There are my new coordinates. Now, you guys can do this with or without graph paper. All you need is to draw 2 axes, and then you don't label them. So my y, my x-axis, my new y, my new x-axis. 180-degree rotation, which is the same positive or negative direction, 180 degrees. So using this tool, you can easily come up with a general rule, transformation rule, saying that x, y goes to, and what that is for a 90, a 180, 270 in the negative direction, and a 90, 180, and 270 in the positive direction. Now, we have already covered what the transformation rule is for 180-degree rotation, and that's the same as a double reflection. Reflect and then reflect gives you the same as a 180-degree rotation, where x, y goes to negative x, negative y. So why don't you pause the video and you try to rotate this shape 90 degrees clockwise, negative direction, and come up with a rule for the 90 degrees, negative direction, x comma y goes to, and we'll see where you are. Okay, so my strategy would be to get a visual first. Actually, before I do that, let's get a coordinate. 3, 1. That's my reference point right there. I'm going to call this point A. And A will become A prime under the rotation. So 3, 1 goes to 1, negative 3. 3, 1 becomes 1, negative 3. So now that I have my point 3, 1 going to 1, negative 3, I can return to the general form of this and say that my x becomes this component here. And actually 3, if 3 is x, this is the opposite of x. And this is y, this is remaining y. So here's my rule. For a negative 90-degree rotation, xy becomes y comma negative x, or opposite of x. Try that for positive direction. And you should have gotten xy becomes the opposite of y comma x. So add these two new transformation coordinate rules to your conjectures. We had a number of them, 4 of them for reflections, and they can be found on page 3 of your vocabulary sheet at the bottom where it says resources in module 1. So to review, not sure about rotations? Rotate the entire coordinate plane. Don't label the axes, and you can reuse them.